We're now on to our next example, or just before our next example, we're going to be looking at the definition of complementary and the definition of supplementary angles. Complementary angles are defined as a pair or two angles whose sum is 90 degrees. So two angles that add up to 90 degrees. They do not have to be adjacent. I could have one angle here and another angle here. As long as the two of them add up to 90 degrees, they are said to be complementary, regardless of whether they're adjacent or not. If their sum is 90, and it has to be two angles that add up to 90 are said to be complementary. We also have the definition of supplementary. Supplementary angles are two angles whose sum is 180 degrees. So students all the time struggle a little bit with, well, what's the difference between complementary and supplementary? Well, one of them adds to 90 and one of them adds to 180. The easiest way to remember is that you know of something else that adds to, if you had two, now they don't have to be adjacent for supplementary, but they could be. So if I had two adjacent angles that were supplementary, they would actually give you something that's 180 degrees. And you know the angle that's 180 degrees is a straight angle. So just like supplementary, if we did connect them, they don't have to, but they could connect to form a straight angle. Supplementary angles, if I had one here, let's say that this is 120 degrees, and this one over here is 60 degrees. Well, they're not connected, but they are supplementary. If I did connect them, though, they would form a straight angle. So that's the easiest way to remember supplementary. Complementary, some people like to remember that one a little differently. So some people like to think as they have to add up to 90. So you can't have obtuse angles that add to 90. Only acute angles can complement each other, or acute angles complement each other. Because if they were not acute angles, if they were obtuse or if they were already 90, then it would be impossible for them to add to or have a sum of 90. And it's not letting me get rid of that. Oh well. All right, scrolling down, finding the complement of an angle. So sometimes we are not given expressions, or sometimes we're given expressions instead of giving the two expressions as saying, oh, they're supplementary, they're going to add to 180, or they're complementary, they add to 90. They're just going to give us an angle. Well, you can call the other angle C if you want for complementary, or I would probably call it X for supplementary, but you can call it S if you want. Just be careful not to confuse it with a 5. C plus 59 is supposed to add to 90. So I have students who, even though they don't like writing equations, this is easier for them to remember than to remember saying, hey, if their sum is 90 and I give you one of them, then you're really going to be just subtracting 90 minus the angle, 59 degrees, to get your answer, which in this case is 30, not 31 degrees when you solve for the complement. We're also asked to find the supplement of this angle. Let's just do complement for this one, and we'll do supplement for this one. By the way, you couldn't find the complement of this because 123 degrees is bigger than you can use for a complementary pair of angles. They have to add to 90, and that's already over 90. So if I look at this as S plus 123 degrees equals 180, since supplementary, like a straight line, add up to 180 degrees, I can take away the 123, and some of you wouldn't write the equation, you would just do this to begin with, and that's fine. And you would get 27 degrees. That would give you the 180, actually not 27, 57, geez, 57 degrees for your answer for that one. 57 degrees. All right, now we're going to take a look at this. This is where people get stumped. like, Mr. Ritter, if you gave me two expressions, then I could make them add to 90 if they were complementary, or make them add to 180 if they were supplementary, and then I could solve for x and do all that. But they get stuck when there's a variable expression, because for some reason they're not in the mindset that if I'm finding the complement, they add to 90, so 90 minus the entire angle. And so they get this mixed up. Now, if you're not going to do that, if you're going to remember to do that, and you're going to remember to distribute this negative, so it's actually 90 minus 7x minus 10, which actually gives you the expression 80 minus 7x, then if you think that you'll remember to do it that way, feel free. That's completely valid and legitimate. But some people get confused and they mess it up. So my suggestion would be, if you're planning to find the complement of this particular angle for letter C, then you write it as, hey, I have this complement over here, I don't know how much it's worth, but these two angles together make 90 degrees. So C plus 7x plus 10, when I add the two together, they should add up to 90. At this point, you're now solving for the variable C. So you don't even have to think about subtracting the whole quantity and distributing the negative, because in the solving process, you will subtract the 10 and you will subtract the 7x, getting that your complementary angle is 80 minus 7x degrees. I'm going to leave that example alone with complementary. If we're doing supplementary, instead of having a 90 here or a 90 on this side of the equation, we would replace it with a 180. So let's do that for letter D. In letter D, we have this expression, and we're going to look and try and find its supplement. So if I had its supplement, I could put them together to form a linear pair, but the two of them together would add to 180. Once again, if you're like, it's a lot of work for me and I know I'm going to remember it because I'm good at that kind of stuff, then you are more than welcome to just do this as 180. The supplement equals 180 minus the entire quantity, the entire angle, 10x plus 3. As long as you'll remember to distribute that negative, you'll get the supplement is 180 minus 10x. Minus 3. And so you'll get 177 minus 10x. But if you're prone to not remember that or forget to put it in parentheses, which would not be good, then you may want to instead say, well, wait a minute, if I have the two angles S and this expression, and I'm just trying to find an expression, I'm not solving for the angle, I'm just trying to find an expression for the supplement, then I have S plus 10x plus 3. Well, supplementary angles are supposed to add to 180 degrees. Now I don't have to think about distributing the negative or putting it in parentheses to make sure I take care of the whole thing. I can just subtract 3, giving me my 177, and subtract the 10x, and get that the supplement is, the expression for the supplement is 177 minus 10x. And because it's an angle, degrees. Example 3, using angle pairs. These two angles in this picture are adjacent, this one and this one. They are adjacent, so they add up to the larger angle. And in fact, not only are they adjacent because they're two angles that share a common ray and a common vertex and add up to a bigger angle, but that bigger angle is 90 degrees. So in effect, there are two angles that add up to 90 degrees. So they are both adjacent and complementary. And so as I go to solve this, I'm going to have the expression, and we're not doing it as a proof right now, 2x minus 1, so I can just write my equation, plus x over 5 plus 25 equals 90. Some of you don't like that denominator, fine. Multiply everything by 5. You are more than welcome to do that to clear your denominator. You could also solve it as it is right now, leaving the denominator. I'm going to multiply everything by 5, though. This equation is going to give me 10x minus 5 plus x. 25 times 5 is 125, so plus 125. 9 times 5 is 45, so it will equal 450. Now I'm going to combine like terms. If this were a proof, I'd have to show all that steps and right next to it. So this is 11x. Negative 5 with 125 is going to be plus 120 equals 450. We're going to subtract 120 from 450, which gives us 330. 11x equals 330. Divide by 11, giving us an answer of x equals 30. Now for this particular problem, they didn't tell us what we were solving for. Actually, they did. So I have to go back and find that. I can't just say x equals 30. That's part of how I get to my answer. But I'm solving for the angle IQU, which uses this expression. So that means that I have to do 2 times the quantity 30, or 2 times 30 minus 1, which is 60 minus 1, so 59 degrees. Now I could also ask you to find its complement, which would be by plugging that into here, since the two are supposed to add up to 90. Looking at letter B is also a set of adjacent angles. They come together to form a bigger angle. In fact, they come together to form a linear pair. Linear pairs will always add up to 180 degrees. This is stated in the linear pair theorem, which we will get to later and prove. But for now, you should know that a straight angle is 180 degrees. So we can set up this equation. 2y plus 17 plus 5y plus 9 equals 180 degrees. By the way, not only are these a linear pair, but they are also supplementary, since the two angles will add up to 180 degrees. We're going to combine like terms, giving us 7y plus 26 equals 180. I'm going to subtract 26 from 180. I get 7y equals 154. I'm going to divide by 7. Y is 22. Don't put that as your final answer unless they ask for it. Just double check. Yes, find y, we did. So there's our answer right there. We do not need to plug it back in. Whereas on letter A, we had to plug it back in, so there's our answer. Looking at a couple other practice problems. C and D, there's actually a couple different ways to set up C and D. And I think I would prefer to do these ones in class. So we're going to skip these in the notes for right now. And we're going to set those up in class. There's actually 2 different ways. One of them follows the expressions exactly as it's written. And another one gets around the problem by thinking about complements and by thinking about supplements. So we're going to save this. Please remind me to go over these. You are going to have ones like these on your assessments. And they're not easy to just figure out on your own. That's not my expectation. So please make sure we go over them. Letter E. On problems like letter E, F, and G, you need to think about what the picture is showing you, what types of pairs of angles you are dealing with. In letter E, we are dealing with this expression and this expression for this angle. We see the big X. We see the angles pointing at each other, and we instantly know that those are vertical angles. We remember that Mr. Ritter told us that vertical angles are always congruent, and that we'll be proving that probably in the next unit. So we set these two expressions equal. 3x plus 3 equals 2x plus 27. And I lost my 27. We get our variable to one side. We subtract 3. X is 24. They did not ask us to solve for x. They asked us to solve for JMK. Angle JMK is not an angle that they gave us an expression for, unfortunately. However, angle JMK is a linear pair with one of the angles that they gave us. Take your pick. Both ones work. You'll get a linear pair. So if I plug it into the expression 3x plus 3, or 3 times 24 plus 3, then I get 75 degrees for this angle up here. Wow, this picture's not drawn very good. 75 degrees is not obtuse, and it looks like it is in this picture. Let me just double check the other one. 2 times 24 plus 3 is not right. So I did something wrong. Hold on. We set those equal. We were supposed to x equals. No, I set it up right. Subtract 3. 27 minus 3 is 24. 3 times 24 plus 3 is 75. I got 75. I just plugged it in the wrong way. So either way, it's 75 degrees. It's just a very bad picture, a bad drawing. You'll find that in geometry. A lot of times they're drawn not to scale, sometimes to deceive you, sometimes just because they weren't thinking about it when they drew it. Okay, I want to pick this or this. All right, so we need this angle, and knowing that this 75 degrees and this angle form a linear pair, I can do 180. I can either do 75 plus the angle JMK equals 180 and solve, or I can just do 180 minus 75 and get an answer of 105. 105 degrees. All right, taking a look at letter F, we are looking at angle QRS. And this must be R, they didn't leave, something happened that got wiped out. QRS. Now normally I would say don't just call it X. You have to make sure that there's no other X's. For an example, I would not have called this X in our last problem, the angle we were solving for, because there were already expressions involving X. And since I didn't know the answer for X, I didn't know how they were related. So I didn't know, X times what plus what is this angle? I don't know. So I was going to solve this and plug it back in first and then solve that separately. So here, luckily though, there are no terms involving X, so it is okay to introduce the variable X. If there were terms involving X, I'd want to try to set up an equation with those and solve it first, and then figure out how the angles are related. Now some of you are looking at this going, what? You got 3 different angles up there, Mr. Ritter. Well, you're right. So they're not a pair of angles, but if I take my orange angle and this green angle and this green angle and put them together, and I add them all together, I get this ray right, or that line right there, a straight angle. So I can write the equation that 52 plus x plus 47 equals 180 degrees. So I'm going to combine like terms. 52 and 47 is 99. I have x plus 99 equals 180. Sorry, it's not writing very clearly. We're going to do 180 minus 99 to solve for x, and we get x to be 81. Unfortunately, that's not what they asked us to solve for. They asked us to solve for QRS. Well, actually, that is what they asked us to solve for. Be careful, though, because had they asked us to solve for, let's call this one T, QRT, I would have actually taken my answer and put it together with the 47. So just always go back and read to make sure that you've answered what they asked you to answer. Take a moment to see if you can set up a system of equations for the next problem. For letter G, see if you can set up a system of equations. All right, welcome back to letter G. Hopefully you identified that you have a couple different options here. There's actually several systems you could come up with. One is to say this right here is a linear pair. So I could write an equation using that. Another is to say, well, look, Mr. Ritter, this is also a linear pair, this and this. So you either have an equation involving the blue linear pair and then another equation involving the green linear pair, or some of you might have said, I wish I can do that, then they're both in standard form and it looks great, but I might also notice my vertical angles pointing to each other, those are also equal, the vertical angles are equal. So there are 3 different systems that you could have set up here. You may have, let me write the one for the blue equation, written that 3x plus y plus 4y, or not plus, yes, plus 4y plus 3x equals 180, because the adjacent angles in this linear pair form a straight angle, they add to 180 degrees. You may have also had this equation, that 4x plus 3x, or sorry, 4y, helps if I get the right variable, 4y plus 3x plus 5x minus 28 equals 180 degrees. Because those linear pairs, those adjacent angles form a linear pair adding up to a straight angle. If you did the orange ones, though, you said, well, wait a second, the vertical angles would actually be 3x plus y equals 5x minus 28, since vertical angles are always congruent, and congruent means they're equal in measure. Any of these equations are good, but now you need to combine like terms and take your pick. If you chose the blue and the green one, you'll have them set up perfectly for elimination, or better yet, even perfectly for substitution. Since they're both equal to 180, whatever this equation turns out to be could be set equal to this equation because they both add to 180, so they have to be equal. If you choose to solve for a variable here or get a variable by itself in the orange equation, then you'll most likely want to use substitution. Please try to work this problem out to solve for x and y. We'll be going over the other example that we had skipped in this video notes, and we'll be doing the try it problems in class after you verify with your classmates that you solved for x and y correctly. Have a great day.